Guys, today is December 1st, and as you know, we're going to be having Advent of Code. And Advent of Code is just we're going to try to solve puzzles from December 1st all the way to 12th of December. Every day, there's going to be a new puzzle to solve. So, let me just quickly show you what it is and just the website in case you want to start solving it yourself. It's fun actually. So this is the Advent of Code website, adventofcode.com and 2025. So I'm Eric. Was I make Advent of Code. I hope you like it. I also make a lot of other things. I'm on blah 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 blah. Advent of Code is an advent calendar of small programming puzzles for a variety of skill levels that can be solved in any programming language you like. People use them as interview prep, company training, university coursework, practice problems, a speak contest, or to challenge each other. You don't need a computer science background to participate. Just a little programming language and some problem solving skills will get you pretty far. Not do you need a fancy computer. Every problem has a solution that completes in at most 50 seconds on 10-year-old hardware. If you like to support Advent of Code, you can do so, blah, 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 blah. If you get stuck, try your solution against the examples given in the puzzle. You should get the same answers. If not, reread the description. Did you misunderstand something? Is your program doing something you don't expect? After the examples work, if your answer still is incorrect, build some test cases. Okay, build test case, verify, blah blah blah. Okay, so guys, let's do day one. So starting this year, there'll be 12 days of puzzle each December. So there's 12 days. This day one is already. Day two is 16 hours from now. We're going to release day two. So let's click on day one. Let's see what's there today. Okay. The one says secret entrance. The elves has good news and bad news. The good news is that they have discovered project management. This has given them the tools they need to prevent the usual Christmas emergency. For example, they now know that the North Pole decoration needs to be finished soon so that other critical tasks can start on time. The bad news is that they have realized they have a different emergency. According to their resource planning, none of them have any time left to decorate the North Pole. To save Christmas, the elves need you to finish decorating the North Pole by December 12th. Collect stars by solving puzzles. Two puzzles will be made available on each day. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. Good luck. Um, uh, okay. You arrive at the secret entrance to the North Pole base, ready to start decorating. Unfortunately, the password seems to have been changed, so you can't get in. A document taped to the wall helpfully explains due to new security protocols. Due to new security protocols, the password is locked and is in the safe below. Please see the attached document for the new combination. The safe has a dial with only an arrow on it. Around the dial are the numbers 0 through 99 in order. As you turn the dial, it makes a small click noise as it reaches each number. The attached document, your puzzle input, contains a sequence of rotations, one per line, which tells you how to open the safe. A rotation starts with an L or arrow, which indicates whether the rotation should be left towards lower numbers or the right towards higher numbers. Then the rotation has a distance value, which indicates how many clicks the dial should be rotated in that direction. So if the dial were pointing at 11, a rotation of arrow 8 would cause the dial to point at 19. Oh, okay. Arrow 8, like 11, you add 8. Okay, then L19, you minus 19. So left, right, you're adding. Left, you're minusing. That will be when we'll start solving. Let's continue reading, sure. After that, a rotation of L19 will cause it to point at 0. Because the dial is a cycle, Turning the dial left from 0 1 click makes it point at 99. Okay. Similarly, turning the dial right from 99 one click makes it point at 0. So if the dial were pointing at 5, a rotation of L10 will cause it to point at 95. After that, a rotation of arrow 5 will cause it to point at 0. Oh, okay. The dial starts pointing at 50. Oh, the 50 is the um how would I put it? Is it the base case? You could follow the instructions, but your recent required official not post secret entrance training seminar taught you that the safe is actually a decoy. The actual password is the number of times the dial is left pointing at 0 after any rotation in the sequence. The number of times the dial is left pointing at 0. How does that make sense? Okay. For example, suppose the attached document. Okay, so you can follow the instruction, but your reasons required official not post secret. And then why did they give us all of this information before? Let's just read on. For example, suppose the attached document contain the following rotations: L68, L30, R48, L5, R60, L55, R1, L99, R14, L82. Following these rotations will cause the dial to move as follows. The dial start pointing at 50. The dial is rotated L68 to point at 82. The dial is rotated L30 to point at 52. That is rotated R50 to point at 0. That's 1, 0. That is rotated L5 to point at 95. R60 point at 55. L55 point at 0, 2, 0. L1 to point at 99. L99 to point at 0, 3 zeros. R14 to point at 14. And L82 to point at 32. Because the dial points at 0 a total of 3 times during this process, the password in this example is 3. Wow. Analyze the rotations in your attached document. What's the actual password to open the door? To play, please verify. Okay, so first we're going to verify ourselves through we use Twitter, we should use GitHub. We just use GitHub, or we just use Google. I don't know. But first the document, the document, is it going to be text file, or let's just let me get my puzzle input. Oh my goodness, this is crazy. Is it day one puzzle input? Oh my god. Look at how long the input is. I think I'm going to just use a text file because I cannot. I think it's going to be just like this one that is just small. I can just write it. I'll copy it and put into a text file, then read it with JavaScript. There's a way to read and take each line. That's what we're going to do. Take each line, put it into into an array. Then we start. Can I control A? Yeah. Did I select everything? Command. Yeah. Command A. Control me. Copy this. Okay. I've started solving now. Where's the one? The one. The one. Um. hmm. So the one is going to have the input. This is the input dot txt. This is the input file. So actually 4,432 lines. Wow, this is a lot. So we're going to find a way to read this. That's what we're going to do first before we start doing anything. And the other one is going to be our code.js. we call it index, I beg. Okay. I like the description of the code, I like copying it inside, so I can just read it. So I'll know, copy this, secret entrance, day one, copy this. I'm going to put it inside, uh, uh, and then just, yeah, I think it's perfect like this. Yes, so now we can just reference it without moving from here. Okay, so first thing we're going to do, guys, so what I'm thinking is the first thing that we have to do is that the text we copied, have to find a way to uh put it from the text file into an array. That's just what we're going to do, but it's too long, like 4,400 plus 4,432. It's a lot of data to put on an array, but that's what I want to try first, sure. So we're going to do that, and then we're, we're going to start solving. So we're going to be in a function, sure. So we're going to just call the function and then pass in the path to the text file, and it will just generate an array from the contents of the text file. So in case the text file changes or something, it can always solve, and you can always get data from it. So that's what we're going to try. That's what we're going to do now. So let's jump into the text editor and let's try that. So I mean, what I meant is going to be the text file is going to be a text file in the function that we're going to create. We're going to turn this text file into an array. Yeah, that's it. We're going to get the text file and we're going to function that's going to this is going to be function is going to be function will help us to do this. It's going to be a function. So yeah. So guys, let's write this helper function to get everything from the text file into an array. Okay. Let me Google real quick. I need to do some things. So the first step successful, we're able to take the text file and then we'll convert it to an array. So it's very long, 4,000 and something lines. So that text file that we copied, but you can put it into an array using an helper function. Then it will be easy for us to then work with the array to try to calculate the password, and then we'll solve the first day of code. So let's continue solving. I might not be talking a lot or at all while writing code, but I'll put nice music when editing the video, so you'll not be bored when watching. But I might not really be talking a lot because talking and I'm not used to this stuff like talking and writing code, so I'll just lock in for some time and yeah. The die starts pointing at 50. The die will tell ST to point at 82. Point at this. The die will tell 48 to point at 0. Right, you add. Left. This is somehow working with the good old pen and paper. So I'll need to write some stuff, and before I start the next step. The next step is just we're going to go through the array and then move it, whether because if it's arrow 5 or whatever, we'll move it, L something, we'll move it, and then if it returns 0, we just add +1 to maybe the count, and then at the end of the array, if there is no more items, we return the total count as the password. um, we only count when we have 0, when we calculate and we have 0, but then the calculating is the issue here, because we need to figure out how to do the calculating. I think it's not just as simple as adding and subtracting, because it starts at 50. So if, for example, the um, first one here is showing L29 in the real one. Let me show you what I mean. No, it says if turning the die left from 0 one click makes it point at 99. So we know that left is actually minus subtracting. So it's going back. Turning the die right from 99 one click makes it point at 0. So we're adding 1. Zero die from one click makes it point at 99. So but what if left 0 plus 99 actually gives us 99? And then right is 99 minus 99 gives us 0. So right, we're subtracting 99. Oh, I get it now. The letter is a L or arrow and the number that follow it. So let's just say, let me show you. Let me write it. Love, not 0. Let me increase this. 0 and 1. 99. 99, 99, 99, 1. 0 and 5. 14. Give 25. Okay. If we add, let me just use here. So tell the number after this. The number after this letter, 10, and this is the starting point. So if the starting point is 5, normal the base starting point is 50 in that main one. This one is just something I draw for reference purpose, but this like something like this is going to be moving. It's going to start at the base, which is 50, but if it's the length is 10, it's going to be 5. Start at the middle. That's what they are trying to tell us. So here now, if you start at 5, for example, and then we make L10 as the rotation, what it will try to do is going to say this 5 minus 10, because minus 10 because it's left, it's going left. Minus 10 is going left. This 5 minus 10 now will give us minus 5. Minus 5 is negative. So we're going to say plus 100, and that is going to give us that 95 here. So give us that 95. For this one now, we're going to do it the same thing. We're just, because it's arrow now, we're going to add. We're going to say 99. We're not going to say minus 1 because it's arrow. We're going to add. We're going to say plus 1 equals to 100. And because it's 100, we're going to subtract. Here is minus 5. That's why we add 100. Here is 100. So from anything that is like, if it's positive, we subtract 100 from it. If it's positive, like, and then if it's negative, we add 100. Will that work? I think that's a good approach to try. That'll give us this. Then for this one, it's the same thing. We're just going to say 0. Because it's left, it's going to be minus 1. 0 minus 1 is actually minus 1. So we're going to say minus 1 plus 100. That will give us the 99. But what if we try for another test case? Let's see this one. It says okay, if is the dial is pointing at 50, the dial is rotated L68. 50 L68. Let's see if it will give us 82. So um so let's say 6 L L 50 L68. Sorry, 50 L68 should give us 82. 82. So L is a minus, so we're going to say the usual is going to be 50 minus 68. 50 minus 68 will be 18, minus 18, sorry, minus 18. Because it's minus, we're going to add 100, so we're going to say plus 100. And minus 18 plus 100 gives 82. So yeah, that's the that's it. That's the objective function. So let's just write, let's write the objective function more, something that is more usable that I can work with. So given function that has base start point, so we're going to say start, and you need to have the whether left or right, so direction, whether it's going left or right, and then rotation. How do you want to turn it in the direction that it is? So we're going to say, depending on the direction, if it's left or if it's right. So um so we're going to say if if direction if direction is L, uh we're going to use this objective function. Then if direction is arrow, which is right. We're going to use another uh ready function. So let's scroll this one here. So f start 50. So it's going to be 50 minus. So it's going to be start. Maybe blue here. Let's use blue. Use blue. So it's going to be start minus. Is it always if it's L, that will minus because it's left. So it's going to be start minus the rotation. Start minus rotation plus 100. Y for right to be start plus rotation minus 100. So that's, I think that's it. Um, yeah, something like that. Let me see if it's true. Sure. Okay, at 95, there is if at 95, let's see 95 arrow 60. 95 arrow 60. Let's see if that one will work. 95 arrow 60. The base is 95. The base is 95. Arrow 60. What is it supposed to give us? 95 arrow 60. It's supposed to give us 55. Um, if it gives us 55 using this formula, then we'll know that this is what we'll use to write our code. So let's um so it's going to be right, the usual, because it's right, we're going to add. So it's going to be 95 plus 60 equals to add 10 to a 155. Wow, is it though? 155. Then we subtract 100 to get the 55. So this is what we're going to be using because it's correct. So this right here is what we're going to be using. This is the formula. Okay. Guys, we're making progress. We have come up with the formula to solve for each rotation, whether it's left or right, then the number that follows it. We know that if it's left, we subtract and then we add 100, and then if it's right, we add, then we subtract 100. So let's turn it into code and let's see if we can. So what we're going to try to do is uh for each line in the for each data, because we already gotten the data from the text. We read it by line by line. So now for each rotation in the rotations array, we are going to get the first letter, or the first string there. The first string is always a letter. So, and then the rest is the number. So if for example we have L and then or arrow, we only pick that first one. So the first one is the letter and the rest is the number. So once we pick that first one, we're going to check if it's arrow. We're going to know the function to use to add or subtract. If it's L left, we'll know whether we'll add or subtract, and that will, then we'll do it in a loop. So It's going to check the next one, and you're going to check the next one, and check the next one. But first of all, we're going to do it step by step, no rush. We have the whole day to solve this advent of code, so there is no need to worry. We're going to solve it eventually. um so what we need to do is we just need to write two functions that we are going to use to test for uh, the base cases that we saw on the website. So once we have test the base cases that we saw, and it works, then we'll know that our function is usable. Objective function is okay. Then we can write write code and start uh, writing loops and all of that. So let's go into the text editor. Let me see how we write it into function to get the rotation, direction, and then the numbers that follow suit. Okay, so we're back, and in the text editor, so um so so we need a function that, okay, so now this the L and this R. So we want to find a way to get this L and this 29 to know which one is it. So to it's going to be another function. We're going to be get um get params. It's going to take a rotation. um so what we're going to do is we're going to get the first one at a string. So rotation, so we're going to get the first one, whether L or R. So const direction equals to the rotation at character 0. So it's going to give us whether it's L or whether it's R, and then the rest of the number. So now what we're going to say is if, now let's just wrap it inside the main function. Then before we start comparing, we're going to say if direction is L, start. If direction is arrow, start. So we're going to have a function that have the start, direction, and rotation. And the start is usually the previous one. But if we're going to be with, if it's the first item in the array, the first rotation on the array, start is going to be 50. But as we go to the second one, the start is going to be the answer that we get of the first one. So we're going to keep updating our stats, but the direction and the rotation will be from the new array, but the stats is always going to be updated. So let's see stats is going to be 50 first. It's going to be let's say let's start equals to 50. Start is going to start at 50. Then we'll call the function that takes start. Hmm. um Rotate dial is going to take in three things. It's going to take the start, going to take the direction, I'm going to take the distance value. Okay, so So this start position, let's start equals to 50, right? You know, you also already know what start is. Start is 50, but you update, you see, rotate that start to update at 50. Yeah. But what if my for loop, um, really for loop for now. Let me focus on this rotate die. So what I'm going to do is rotate die start direction distance value. With something. You will do it and then it starts. I just say the start is 50. The direction. Oh, what if instead of saying start, what if I just say start and the next rotation. Next rotation. Start and next rotation. Start and next rotation. I don't even pass in the direction and distance value because I'm going to use the get params function inside the rotate the function. So instead of doing this, I can just say start and next rotation. Next rotation. So what I'm going to see is I'm going to get params rotation. Instead of doing this, I can just say so next rotation is going to give us direction and a distance value, right? So you give us direction and distance value. So we're going to see you get from this. So when we start, so what we need to do is if direction is L, um what why is it modulo there in the formula? There's no modulo in our formula. I don't know what's wrong with way to update the start, which is start minus rotation plus 100. Start minus rotation plus 100. So we're going to say password. No, not password, but um if you rotate it's going to be a new position. Get new position equals starts minus rotation plus 100. That's my revision. We start position minus rotation, which is usually whether the distance value starts distance value plus 100. Um, then if and then if everything equals to arrow minus 100. That's it. That's a new position. Now, once we get the new position, you can just say nice. Okay, we'll have the new position equals start position equals 100, and then if direction equals to r, new position equals to, and then we return new position, return new position. So let's try it. Let's rotate dial on, return. Let me just use console.log so I don't have to write so much. So rotate dial. Let's use that face on 50. And here it says, for example, we could for the it starts at 50, then L68. If it give us 82, then we're good to go. 50, next rotation is L68. Let's run the code. See, 82. Check nothing. That one go. So 82 L30. Let's see if it will give us 52. 82 L30. So 82 L30. 152. Okay, instead of 52, it's not giving us 152. So because we're adding 100, we're still adding 100 when we're only going to add 100 if start position minus distance value is less than 100. Okay. If start position minus distance value is less than or equal to 100, then we add 100. Otherwise, just leave it like that. Is less than or equal to 100, Or if it's less than or equal to 100, it will be the same thing. No, less than or equal to 100. If it's left, if it's less 100, it will always be less than 100 now. 82 or 30. 82 plus 30 will be 1, 2, to be minus, so to be 52. That's just it. It's just supposed to be 52. Is greater than 100. New position is this. Else, like if is not greater than 100, new position will just be this plus 100. I'm going to do the same for this one too, for the arrow. So just that small fix. Stop giving us errors. Start if direction equals to arrow. If start position minus, no, it won't be minus for this one because it's arrow, it will be plus. If we add it now and it's greater than 100, new position will be this. If we add it and it's greater than 100, um if we add it and it's less than 100, sorry, this plus this, else new position will just be this plus this minus 100. Okay, I think uh this should work now. Let's see, giving me 152. Why is it showing me 152? Oh, I don't know. New position equals to start position minus distance value. Then return new position is put it into an else, not just be me 152. If it's less than 100. If it returns, it's supposed to end. It will end there. I don't know. Why is it showing me 152? Because this console or log that means instead of return. Maybe. Let's see. It should show me 152. I have to do if start position, which is here is 82. If start position minus this is less than 100. If it's less than 100, then do this. Else, do this. This one, if we add it, because it's arrow, when you add and it's less than 100, leave it as it is. else it is 52. Okay. Okay, let me go to the next one. Let me see if to work. We'll keep updating this our rotate die function till work for these test cases. Yeah, you to point at 0. Okay. 52 and arrow 48. Let's see if it will give 0. 52 and arrow 48. See if it gives 0. So rotate dial 52 and arrow 48. Arrow 48. See. Okay, 0. Okay, that's good. 0 and L5. 0 and L5. So 0 and L5. Minus 5. Oh, now of which error now? So you see, it's greater than if greater than is greater. Oh, less than or equal to. Less than or equal to. No, greater than or equal to. But if it's less than, if it's greater than 100. Hmm. Is greater than or equal to 100. We're supposed to minus 100 from it. Else, we'll leave it like that. I think that's this little fix. See minus 5. Start position, this one for into the function again. Okay. Is what if it's what if it's greater than what if it's greater than start from here. One, two, three, four. Mm, If direction equals to r, if position for distance, start position is 0. Wait, plus going to add distance is less than 100. is less than 100. We're just going to bring this. Oh, it's not doing. That is for the. See for the yellow. If start position minus distance is less than 100, minus 95 is less than 100. Oh, no, no, that's the wrong approach to this. I'm supposed to um do the start position minus distance value first. Then depending on what I get, if it's minus, I add 100 to it to make it become plus. And then return it. So if it's less than 0, that's what I'm to go and that is what I'm supposed to check. If it's less than 0, I'm going to add 100 to it. What if it's not less than 0, but it's greater than 100? So I'm going to go on that if. I'm going to check if it's less than 100. It's going to look like this. Else, it means it's not less than 0, it's not less than 100. It means it's greater than 0 and it's greater than 100. Then we add it. This. So yeah, 95 now works. I think I'll do the same for this one. For the for the arrow. Do the same for the arrow. If so, this one we're adding. If we plus, if we add it and it's greater than 100, we're going to minus 100 from it. This one, there's no way to give us minus if we add, because we're always adding. It will always be greater than 100, greater than or equal to 100. Then we minus 100 from it. If else, we return the normal thing, which is this one. Um, so let's go and try. Let's try for the next one. 95 arrow 60. Let's see if it will give us 55. 95 arrow 60. Testing is stressful, but we have to test it to know if what we are doing will work. 65. Oh, it's giving us minus. Why is it giving us minus now? Hmm. I see. Question is arrow. So what we did is yeah, it was a minus 100. It was supposed to add 100. think it's minus 100, yeah. Yes, yeah, minus 100 when it's greater than 100. Greater than or equal to 100, we minus 100. But that's after we have add this value. So it's going to be this value plus this value. Oh, for left is minus, right? For this one, we're going to add it. That is a mistake. Add and add. So, so 55. 95 arrow 60, 55. Is that what is there? Yes, 50 point at 55. 55 L 55 supposed to give us 0. So 55 L 55 0. Lazy me, I don't want to test everything. 0 L1 supposed to give us 99. 0 L1. Guys, so our rotate dive function works now. So passing the start, the direction, and it will give us what we need. That is the next. It's going to give us the next position depending on L on arrow. It's calculated. We have tried it with with the test cases on the website and it works. So let's just move on with the problem. Let's continue. I think now is to use the try for loop and go through each rotation in the rotations array and then do the rotate dive. Whenever the rotate dive gives us 0, we just count plus 1 and till we get to the end of the array, then we return the count as the password. That is every time the rotate dive gives us 0. That's what the problem said to ask us to do. So let's see. I think this is a rotate dive. Start position with 50. Well, I want to put all this. This one is going to be in a function. This rotate dive is a function is on. Start position is going to be in the new function I want to create that is going to calculate the password. So I'm going to say calculate password equals to, yeah, rotation codes. Just tab everything, tab. Okay, so what we're going to do is we're going to um iterate through everything in the rotation codes array. So we're going to say for let code let rotations of rotation codes. So each rotation now, rotation codes. We're going to do the rotate dial. First, start position is always 50, right? Start position is 50. Oh, we're going to let the start position here will not be what? Distance value. Oh, it's supposed to give me new position. This rotate dial supposed to give me new. Okay, so it give me new position, which is 55. Okay, nice. You give me new position. Even though if I rotate it, it just give me the point. If I say if it's out of 55, it starts at 50. Oh, okay. Okay. Start position equals to 50. It's going to be inside this calculate password. So for less rotations of rotation codes, um, the new position is going to be the rotate dial that we made. So tab as a new position. Now if equals 0, um let password is nothing. Let's just say let password equals 0, because it will be if new position equals 0, password plus equals 1, so pass 1. I'm going to increase password by 1, so that's it. If new position equals 0, if it's not 0, go. Even though it's equals 0, password plus equals 1. The new position will be, no, I'm not going to use for loop. Well, I'm not going to use for loop because I need the next um I need the next one to be the start position. I need this start position to change. Can it change here? Let me see. Start position equals to new position. And then it does it rotations. Do. Will it work? Then return password. Return password. So here, instead of doing console.log rotation codes, I can just say calculate password rotation codes. Password let, and then we console.log the password. That's it. Right. We'll try it with inputs.txt. Let me do another input too. Let me say input too. Let's test.txt. That is the one that is in the website, which is this one. It's small, so that we're going to just use it to test the code that we will write. L682 is so test.txt. So instead of go back to our code, so instead of input, it's going to be test. So let's see. Yeah, it's giving us a lot, giving us give me minus 65. Why you give me minus 65? I don't know. So no number. Need to be the start for, is it minus? No, you're not supposed to give the this thing there is the answer there. You know, let me create new terminal. From this one. Oh, the one. Okay. What is this? Oh, we will get for calculate arrow, calculate. Oh, I think let me do that. The rotate dial. If you equals to R, equals to L, I'll just calculate R, calculate L. So we need the start position and distance value. So start position, calculate L, calculate L, this will be 8. I don't like the no, what is this? What is this? Tell me what is mine, but I ain't true. If direction equals to L, L start position, this one will, if direction equals to arrow, our start position, this one will, yeah, I think now I should do. Let me leave this calculate password for now first. Let me see if this my rotate dial is still working. Maybe 50 is um new this direction, this is new position. Here is at 99. Example, I will see R1 supposed to come on, enter 0. What the heck? I want to break this thing. Start position. The rotate dial now works well because we have these tiny little functions that does a lot. Calc L, calc R, calculate left, instead of calling it calc L, why don't we just call it rotate L, rotate R, rotate left, rotate right, and then you can see rotate dial. So if direction is left, we rotate left. If direction is right, we rotate right. And that is our new position. New position. Ah, so that's it for rotate dial. Rotate dial works. So what else is the calculate password now? Let's start position equals 50. Password is 0. I'm not going to use this for loop. I'm going to say I equals to the visual cursor length um no, I don't know what this code is doing. All we need to do is calculate code while I is less than or equal to. We for when check the rotation code, the first one see if it's on well, let's check because 0j is less than what to I, right? Length, okay, less than I. Less than I. A plus a consultation because next rotation is original equals J K, new position equals rotate dial, start position next rotation. If your password equals one, start position equals to new position, and then at the end we're going to return password. So I think this is it. I don't think there's anything else to do. I think this is it. Um, let's see if a test works. Ah, I think it's three for the test. Three. Yes, finally. Guys, finally we have solved for we have solved it. At least our code now gives us three, which for the test case, this text file, the text file that we got from the website, we just copied their own rotations, put into a text file. Our code gave us three, and the answer they got so is three. So our code works. It's pretty long. The code is, but not too long. I wrote, I broke it down into functions. So if you are going through the code, you know what it's doing. You know what each function is doing, and I'll share it in my GitHub for those of you that want to, just play with it. You can check it out. Um, so the next thing is for us to find the solution to the one that we copied that is 4,000 and something long. I don't even know if my code will be able to do 4,000 something long. But let's try. If it takes too long, we'll try to optimize the code. But I'm sure um you should be able to do it now. Let's try it, sha. Let's see. Alright guys. When we calculate the password test for the test, we gave the for the example is three, yeah, and our own too, uh we got three. So our code runs fine. So we're going to let's clear screen. So now instead of tests, we're going to use input, the one that they gave us. So if we run this, we just copy the answer, drop it there, and see. So node index 25. It give me, is it, what did it give me? 45. 45. Oh, I want to be sure, you know. Um, yeah, okay. I'm not in the day one directory. 45. Okay, so the password is 45. Let's just put it there. 45. Submit, and oh, it's not correct. Wow. Okay. Crazy. This is the puzzle input we got, right? Ending out tray. Wait, let me see. Am I sure I'm copying the right thing? Where is the input text? The ending out tray. Ending out tray. So there are a lot of arrow 816. Wow, there are a lot of number here. So I think the reason why it's giving me 45 is because there's nothing wrong with my code. Um, but for this their own, it gives me 3, which is the correct answer. But for the main one, it's not giving me the correct answer because there's something wrong with my code and I have to fix it. Um, so we go back here. Let's see. Wait, what if arrow 800? I see arrow 800 and something there. How is that supposed to be something? Arrow 800 is way bigger than 800 is way bigger than 100. Arrow 800 is adding safe. So if we see 95 and arrow 800 will be 895. 895 is way bigger than 100, so it's going to be 895. No, I've seen this issue. If we have something like if we have something like this, let's see, where is this one? If we have something like this, if we have something like 95 arrow 800, for example, using this our own, if we say 95 level arrow 800, it's too big. If using this our own, we'll do 95 plus 800 abi equals to 895. We'll now minus 100 once, which will just give us 795. So in this our own, we're assuming that the highest value that they can give us, the value that they can give us will not be more than not be more than 200. That's what we're assuming, which is wrong. But they can see now this one, that one now I'm seeing 800 in this one we copied. I just went through it now. And over here, see this one 900. So see, I'm seeing 900 and something. In a situation where we're getting 900 and we're getting uh large values, what we need to do is we need to find a way to just get this 75. So it's going to be, so the way to get this the way to get this 95 now, 95 800, 95 plus 800 minus, you give you 95. It starts at 95, you do 800 times, right? 800 times. So we're going to say 895. We're going to get the remainder when you divide 895 by 100, 95. So instead of minusing, we can just say the remainder when we divide by 100. And yeah, so instead of minusing, we can just say the remainder when we divide by 100. What if it's minus and it's large? Um, hmm, does not matter if it's minus. I don't think the sign don't matter. Can just do the absolute of the, for example, 5 minus 10. We don't really care which one is big or small. I don't think that's the point there, whether or not one is bigger than the other. I think if we find the absolute value of 5 minus 10 is 5, and we can just do 5, the remainder when 500 divided by it to be 5. So it should be 5, and then so assuming this we have 95 as the start, we have something like right 800. um it's going to give us 95. We know, wait, let me see, this is just some more. Okay. Yes. um we know is R800 is large. If we use the one I came up with before, we're going to see 95 plus 800, which is 895. Then we'll subtract 100 from it, which is wrong. um what we need to do is we need to do um we need to divide by 100 and find the remainder. And how we can do it is find the modulo. 895 100, 895 divided by 100 um is 8 times, and to remain 95, because 100 cannot go in 95, so it will give us 95. And because 95 is less than 100, it just gives us 95. 95 is not negative sign, it just gives us 95. So when we add it, we first need to do this division, this small change. And let's do this small change in, and then let's see. So let's do it in our code directly. I think we'll do it, let's do it in our code directly, or should we update this one first? um I think we should update this one first, just for the sake of it. Let's just update this one. So 100, so yeah, something like this. So it doesn't matter whether or not this value here, if this value here is 0, it's going to give us 0, so it's not going to affect um the output really. But we're just reducing it, so it takes off this extra value here. So if it's 1000 and something here, it doesn't really matter. It gives us the one that is here, which is the one that is important, the one that we need for the rotation dial, whatever. Think, yeah. So let's put it into code. Let me go to index. So now rotate left. So first, what we did first, we minus it and we check if it's less than 0. No, we want to save the minus and the modulo. So we're just going to add the modulo to it. So we're going to add where we just going to put the modulo, and then this one the same thing. I'm going to just put the modulo. Now if we're going to put the modulo, because we don't know whether or not it's big, we'll put the modulo. Then put the model. So I think this is all we need to do here. Just that, and the same thing for the rotate arrow on down. But we're going to check though. We're going to check it with the test again, and if it gives us three, then we'll know um, in the right direction. We're going in the right direction. Let's see. So let's, instead of input, let me just say test. So we run this. Okay, it gives us three. So okay, this is wonderful. Three. So we just the little change we made, and it gives us the same answer. But let's put in the input now that we copied, which is over 4,000 um 4,432 rotations. And if we put that in 1,066, so the first time when we did it, we got 45, and now when we figured out uh, um yeah, we're seeing numbers that are huge, like 912, 900 and 800 and something. It's very huge number. So to reduce it, we'll just divide, and when we divide, the test gave us the same answer, so we didn't really break anything. And then the input gave us another answer, gave us 1,066. So we are actually going somewhere. So what I need to do now is just copy 1,066 and paste in the website if it's correct. Fingers crossed. Hope it's correct. Let's go back to the website, and then um 1,066, and then submit. Yeah, correct. So now that's the correct answer. You are one gold star closer to decorating the North Pole. Is that there's a part two.